This example is 2 years of production data from the Barnett Shale. This is a multi-frac horizontal well. We're going to analyze this data in harmony. We'll start by looking at a diagnostic plot, a logarithmic plot of normalized production rate versus time. The Fekete type curves in the background provide a useful backdrop to indicate whether the well has transitioned from transient flow into boundary dominated flow. Transient flow curves are up here, the boundary dominated flow curves are down here. As we can see, the shape of this data indicates that it is somewhat of a harmonically declining data set, indicating that it has gone into boundary dominated flow. Let's take a look at Wattenberger. The Wattenberger diagnostic plot is also normalized rate, but it's plotted against material balance time. And there's also a derivative plot on here. The derivative plot can help us indicate the flow regimes that we're seeing in this well. The type curves in the background are bounded linear flow. What we see here with the red data is that there's probably some skin. That's why the data is not matching precisely on the type curves. The blue data is really what we're interested in looking at. This is the derivative data. As we can see, there's some linear flow at the beginning. This is a half slope, but a fairly quick transition into some boundary dominated flow, or boundary influence flow anyways, after a short period of time. So we have a well that doesn't have a whole lot of transient flow and seems to be transitioning into some boundaries fairly quickly. So let's take a look at the unconventional gas module. This is our simplified decline curve analysis methodology in RTA for unconventional wells. There are 4 plots on this page. We have our square root of time plot in the top left-hand corner, our flowing material balance plot on the right, and then type curve and forecast on the bottom. We're going to start on the top left-hand side and look at the square root of time plot and see if we can determine what's happening here. Straight line analysis on this indicates linear flow. As we can see, the linear flow is occurring at the beginning. This line must intercept at the origin or above. So we can see we have some linear flow at the beginning, but then we can see a departure of the data from the straight line in the upwards direction, which is a clear indication that we're seeing some boundary effects. The boundary effects are most likely from interference between adjacent fractures, since this is a horizontal well with multiple fracture stages. To get the correct analysis, we want to position this green line such that it occurs right at the departure point, or as close to the departure point as we can. So let's first position the red line with the proper slope. To move the location of the green line, which is the time to end of transient flow, we go over to the flowing material balance plot and adjust the extrapolation of that plot. Now we can see everything else changes on these 4 plots as we do that. And if we extrapolate this properly, we should be able to set it just so that that green line occurs at the departure point. And that should also give us a fairly good extrapolation, or straight line extrapolation, of the flowing material balance plot, just like this. From the results of this, we can see that the original gas in place is somewhere in the vicinity of 1.7 BCF. Now it's important to understand that that original gas in place applies to the drainage area of the stimulated rock volume. And the stimulated rock volume is defined here as whatever is contained within the fractured region where we first start to see the interference. So if we interpret it this way, which I think seems to make sense for, say, P90 reserves, we can then go and produce a forecast as we see in the type curve below, and the forecast plot on the bottom right. The decline curve properties of this forecast during the boundary dominated flow region is a decline exponent of 0.5. And the drainage area of the SRV in this case is 16 acres. Now if we enter in the horizontal well length, the number of fracture stages, this will actually calculate the matrix permeability. And the assumption here is that there is one single planar fracture per stage, and they're evenly spaced and they all have the same length, which of course may not be true, but is an approximation. So our matrix permeability then would be roughly 0.001, which would be 1,000 nanodarcies or 1 microdarcy. For the Barnett Shale, that's a reasonable approximation of matrix permeability. So it shows that our assumptions here are most likely reasonable assumptions for this well. The drainage area is 16 acres. The fracture half length, or the stimulated reservoir width, half width is 275 feet. So we have stimulated rock volume going out 275 feet on each side of the horizontal well. Our expected ultimate recovery looks to be about 1.1 BCF, or in that range. The assumption here is that this stimulated rock volume will essentially deplete like a tank. That may not be the case, but it's a good P90 approximation. In this particular instance, we may want to investigate cases where the boundary-dominated flow takes more of a heterogeneous track through time. So let's investigate additional type curves. In this case, we're going to keep the drainage area to 16 acres, but we're going to find out what would happen if maybe we remained in a harmonic decline rather than going into a B value of 0.5, which is fully boundary-dominated flow. The assumption here with a higher decline exponent would mean that maybe there's some pressure support from outside the stimulated rock volume. This could occur if we have some fractures that are longer than other fractures. It could also occur if we have support from unstimulated matrix rock feeding into the SRV. It could also occur from adsorbed gas contribution through time. So this is a very reasonable alternative forecast that we should investigate. So I'm going to add this one in there, and we can see now that's the orange line. This one might make a good P50 forecast because it actually continues along since if we go back to Fekete, the look of this data appears to be harmonic going forward, making the assumption in the forecast that it remains harmonic is probably not a bad assumption.